Welcome to this course on Terraform certification training. This course is all about the Terraform. So in this certification training, we are going to cover the complete HashiCorp Terraform certification material with the practice exams. Also, we will cover the Terraform in real time. We will see how we can use the Terraform in real time, how we can deploy the resources using the Terraform on AWS and GCP. So team, welcome to the Terraform certification in-depth course. I am Anshul Chauhan and I will be your instructor throughout the course. I have a decade of experience in IT and having the core expertise in DevOps and DevOps tools. So here in this Terraform training, we are going to cover the two aspects. First, we will prepare you for the HashiCorp Terraform certification exam. So you would be able to get enough knowledge to clear the HashiCorp Terraform Associate exam. Along with this, we will share the Terraform real-time example. We will share the multiple labs on Terraform implementation, that how you can automate your infrastructure using the Terraform. So this course is just not for the Terraform certification, but it is more than Terraform certification along with the Terraform real-time implementation. Multiple practical labs and real-time scenarios using the Terraform on AWS and GCP is going to be the part of this course, so that you can get the real-time experience and you can use the Terraform in your projects. We are going to explain each and every component of Terraform certification syllabus so that you would be able to crack the Terraform certification exam easily. We are going to implement the infrastructure using the Terraform on public cloud like AWS and GCP. You will also learn that how we can include or use the Terraform with the tools like Packer and Docker. While you will complete this course, you will get the completion certificate from the Udemy. This course have the fully coverage of the HashiCorp Terraform certification. So if you want, you can attempt the Terraform certification and you will become a Terraform certified engineer. We are going to share a multiple hands-on knowledge and you would be able to apply the Terraform from very starting of this course. There's a one more note I would like to share, that is about the Udemy rating. Udemy asks for reviews very quickly, even after 15 minutes. So if you are liking the content of this course, you can rate us 5 star. Otherwise, you can choose another option, ask me later, and later you can leave the rating for this course. So that's all for the introduction lectures. Welcome to the Terraform training. Let's start with the Terraform certification and Terraform implementation. Thank you, team. See you in the coming lectures. Hello, team. Welcome back. And before starting with the Terraform implementation, first let's go through the Terraform Associate Certification exam details. So we are on Google and we will search for the Terraform certification exam. On our search, we will get a link HashiCorp Cloud Engineer Certification. We will click this and here you will get the Terraform Associate Certification details. Here we are getting the prerequisite, we are getting the product version. So currently Terraform certification is available for the Terraform version 0.14 or the higher. Here we are getting the exam detail. You will get the multiple choice questions in your exam. The exam mode will be online and total duration of your exam will be 60 minutes. This exam is going to cost you 17 and half USD. This is American dollar. In your local currency, this amount may be different. The exam will be conducted in English language and the expiration period of your certification is 2 years. Now here are the details or the syllabus of your Terraform certification exam. You will get the questions from the understanding infrastructure as a code, right? And you need to describe and explain the IAC. The next topic is the understanding of the Terraform to support the IAC, which will include the cloud agnostic benefit of the Terraform or the Terraform benefits. Then we have the understanding of the Terraform basics, and here are the few topics which you need to go through. Then you need to learn about the Terraform CLI. CLI means command line interface. We need to learn about the Terraform format, Terraform tent, import, workspace, and the state. Once you will cover the Terraform CLI, you need to learn about the Terraform modules, that what are the modules in Terraform and how we can use the modules to reuse the code or reuse the block of Terraform codes. Then you need to learn about the Terraform workflow. You need to learn that how Terraform workflow work whenever you are going to deploy the resources using the Terraform. Then there is another important topic, the implementation and maintenance of the state file. So for now, you can understand Terraform state files are the database of Terraform. You will learn about the implementation of these state files and you will learn about the maintenance of these state files. Then there is the eighth topic, which is read, regenerate, and modify the configuration. So here you will learn about the configuration of the existing deployed system. Then there's a last topic about the understand Terraform cloud and enterprise capabilities. So Terraform provides the free version and commercial version. You will learn about the difference between the free version and commercial version. You also learn about the Terraform cloud and how Terraform cloud will help you to manage the Terraform resources. So these are the 9 topics which are covered within the Terraform associate certification. We are going to cover each and everything, whatever the part of this Terraform certification syllabus. So these are the details of the exam. From the very coming lecture, we will start learning about the Terraform. Thank you, team. See you in the coming lab. Hello, team. Welcome back. And with Terraform fundamentals, first we will start with IAC and IAC benefits. We will learn about the IAC and we will learn about the role of Terraform in IAC. So IAC is a very popular term which stands for infrastructure as a code. So what does it mean, infrastructure as a code? Infrastructure as a code means whatever the deployments or whatever the resources you are creating as a part of deployment in your cloud. These resources or these deployment will be created by a code. No human intervention required to create the deployment or resources over the cloud. And that is the purpose of Terraform. Terraform as a tool enables the DevOps engineers to code the infrastructure. So within a Terraform, you can declare the complete infrastructure and you can create the infrastructure with the help of Terraform. Whenever we are using IAC or whenever we are deploying the resources with a Terraform, it means no manual deployment. Everything, whatever you want to deploy, that could be the VM, disk, applications, all could be written down in a code which is a human readable code files. IAC can replace the manual deployment, and whenever you are using the IAC or you are using the deployment via Terraform, you don't need to create any deployment manually. Terraform and the IAC have the another benefit that it will enable your DevOps team. Your DevOps team can code the complete deployment creation process, and that can be versioned in the version control system or VCS. It means if your product have the multiple release, suppose there's a release X and in future you are planning release Y, so your deployment code is also versioned. For release X you can use the release X deployment code, and for release Y you can use the release Y deployment code. So what is the benefit of the version deployment code? The benefit is, suppose in a release X you have some services like ABC, but in release Y you are going to add one more service called D, and there is a change in service ABC as well. So if your code is versioned and in future as well, if you want to deploy the release X, then you are able to deploy the release X, although your current production is running on the release Y. So like your software code versioning, you can also version the deployment code. The another benefit of the IAC in Terraform is you can declare your infrastructure. Whatever the infrastructure you are going to create, that may have the 10 VMs, that may have the network, that may have the single network, load balancer, storage file, disk, anything whatever you want to create, you need to declare all your infrastructure in the Terraform declarative files, and anybody can read that file and they can understand that what is going to deploy as a part of that particular deployment. So let me share a basic example. So right here we have a sample Terraform file. Right now you are not familiar with the Terraform syntax, so don't worry about it. We are going to explain that as well. But we are just understanding the declaration of the infrastructure. So over here you can see we are declaring the provider AWS. It means we are going to use the AWS public cloud. In the AWS we have the profile default and we are going to deploy the resources in US West 2. What are the resources we are going to deploy? We are going to deploy a resource AWS instance, and that instance is going to name app server. This is the AMI what we are going to use as a part of this instance, and this is the machine size of the instance whatever is going to deploy as a part of this file. This machine will have the tag example app server instance. So you can see this is the declarative syntax of deployment in a Terraform. Once you will execute this particular file, it will deploy a VM name app underscore server on your AWS. So it means IAC in Terraform is also a declarative. The another benefit of IAC is speed, cost, and risk. So whenever you are going to deploy the environment manually and you are going to deploy the environment via Terraform. So whenever you are going to deploy the environment manually, it will impact the speed. It will also impact the cost, because if you want to deploy the 5 environments, then it may possible you may take 15 days or 20 days. But if your infrastructure is ready as a IAC, it means you can deploy your infrastructure via Terraform. Then you can simply execute the Terraform files, and Terraform files will create your environment even within few minutes or within few hours. So it is increasing the speed of your deployment. It is also saving the cost, and it is also minimizing the risk of manual configuration error or redeployment, right? So you can understand that whenever we are going to deploy the environment manually, that we may create the errors. We may create the error in the configuration, we may create the error in the sizing, then it will introduce the rework, it will impact the overall deadline or overall timeline. So if you are ready with the IAC, you are ready with the Terraform, then you can simply execute the Terraform declarative files, and you can create as much as you want number of environment via Terraform within few minutes or within few hours. No manual intervention will be required. It means less chance of the error, and whenever we are getting the faster deployment, it will improve the overall business impact. So that is the IAC, and that is the benefits of IAC. In the coming lectures, we'll start learning about the Terraform files and hands-on practice using the Terraform. Thank you, team. See you in the coming lecture. Hello team, welcome back. In previous lecture, we have discussed about the IAC and the benefit of IAC. And today we will discuss about the infrastructure as a code with Terraform. That how we can use the Terraform to create the infrastructure as a code. So Terraform is an infrastructure automation tool which will help you to automate the software defining deployment network. So suppose you are getting a requirement to create a new production environment to support the more clients, and as a part of your production environment you need to create the n number of deployment, and these n number of deployment have m number of resources. That could be the combination of the load balancer, VM instances, disk, network, DNS names, and many more things. So Terraform is a tool which will help you to automate the deployment network. It means with the help of a Terraform, you can create the complete deployment network, and in a single click, you can start deploying your complete environment. Another benefit of IAC with Terraform is that Terraform support the vast range of public private cloud providers. That is true. Within the Terraform, you will get a support of multiple public cloud providers or the private cloud providers. So let me show you some cloud providers which Terraform supports. So we are searching for the Terraform providers list, and over here we are getting a link for registry.terraform.io. If you will open this link, this is a Terraform registry link. Over here you can see these are the providers, right? And here we are getting almost all public cloud providers: AWS, Azure, Google Cloud Platform, Kubernetes, Oracle Cloud Infrastructure, Alibaba Cloud. And over here we are getting the different filters, that what are the official cloud providers. So here are the official cloud provider. You can see AWS, Azure, Google Cloud, Oracle Cloud, Kubernetes, Active Directory, Archive, Azure Active Directory, and there is a very long list. You can see there is total 34 official cloud provider. If you will go with the verified and uncheck the official, then these are the verified. We are getting Alibaba Cloud, and there is a long list. You can see there is a very long list which is verified, and total 145 verified cloud provider are here. So Terraform have a very vast range of the cloud providers, and you can create the resources in any public private cloud provider which is listed over the registry.terraform.io. There is another benefit with the Terraform, that you are not bound with a single public cloud provider. With the help of the Terraform, you can deploy your environment across the multiple cloud or hybrid cloud. It means with the help of the Terraform, you can deploy your same environment on AWS, on Azure, on Google Cloud, or on some other cloud. So what is the benefit of it? It is making your environment cloud agnostic, that your cloud is just not depend on a single public cloud provider, so that if there is a failure in the single public cloud provider, you can use the another public cloud provider to serve your customer. So multiple organizations have the primary site and the disaster recovery site for the production environment. And the topology is like that primary site is running on the different cloud and the disaster recovery site is running on the different cloud. So that if they are getting the issue with a single public cloud provider, the disaster recovery site will be active. It means the other public cloud service will be active to serve the traffic to the customer. So with the help of the Terraform, you can deploy the environment across the multiple cloud. There's a one more possibility. With the help of a Terraform, you can deploy few of your services on the on public cloud one like AWS, and few other services on the public cloud two like GCP, and few other services on the public cloud three like Azure. So it all depends on your requirement. You can design the Terraform declarative syntax in any way, and you can use that to deploy your environment across the multiple clouds. Terraform have a very rich tracking system, and with the help of the Terraform, once you will deploy your environment, any point of time in future, you can track the state of each resource you deployed with the help of a Terraform. So if someone have changed the infrastructure manually after you deployed the infrastructure, you can check your infrastructure state by a Terraform, because Terraform track all the resources which is being deployed by a Terraform. So that is the benefit of IAC with the Terraform. Whenever you are using infrastructure as a code with Terraform, you will get the multiple benefits. In market there are multiple providers which are providing these kind of support, but Terraform is a very famous because Terraform provide a very vast support of the cloud providers, right? And Terraform provide many other features as well, which we are going to learn further in this course. So thank you team, see you in the coming lectures. Hello team, welcome back, and today let's discuss about the Terraform workflow. So we will discuss about the way that Terraform is going to deploy the environment on cloud. Terraform workflow is basically divided in three parts, and first part is Terraform configuration. So in the very first phase, DevOps engineer or the software engineers need to write down the code files for the infrastructure. Whatever you are going to deploy as a part of your deployment, everything needs to be defined, and that must be defined in the Terraform configuration language, which is called HCL. So in the first phase, we are just making the code files, we are just making the Terraform configuration file, which are going to deploy the infrastructure. And second phase is the plan infrastructure. That is also called the review phase, because in this particular phase, you are going to review whatever you have written down in your configuration file. So Terraform provides a way that before going to start the deployment, you can review that what you are going to deploy. In this particular phase, user can execute few commands which we will discuss, and they can see what is going to be deployed as a part of that deployment. These two phase, the write Terraform config and the plan infrastructure, these are the cyclic phase. So whenever you are going to review, and if there is any configuration missing or if there is anything extra, anything less, then you can change your code as necessary and make a review again. If there is still some issue, there is still some more resources which you want to add, you can again update the code and review it. Once you will finalize the infrastructure plan, it means you have reviewed all the resources which are going to be deployed as a part of that infrastructure, and all the statements are correct. The final phase is deploy infrastructure. In this phase, you are going to apply all the changes, all the configuration file you have written down in Terraform, and you are actually going to deploy your infrastructure. Within this particular phase, all the resources which you are creating as a part of your infrastructure, that is going to be created on cloud. So that is the complete workflow of Terraform. The first two phases are the cyclic phase, and the deploy infrastructure is the final phase. We will see the complete workflow of Terraform. There is nothing to worry. So thank you team. See you in the coming lectures. Hello team, welcome back. And today we will discuss on initialization of Terraform. So we will see what is the Terraform initialization process and why we need the Terraform initialization. So in Terraform, you will get a command terraform init. That command is used to initialize the Terraform. Once you are going to execute this command, that is going to initialize the working directory of your source code. Terraform init is a mandatory command, and before you execute anything in Terraform, Terraform initialization is must. So basically Terraform follow a directory based structure, and in a particular directory, if you have all your code files which are going to be deployed as a part of Terraform, then very first you need to initialize the Terraform so that Terraform will mark that directory as a working directory for your deployment. Once you will execute the Terraform init, the few things will happen. Very first, Terraform will download all the supporting component. That could be the modules or plugins. We have not discussed about the Terraform module, so that is a new thing. But later on, you will see how we can use the module and how we can create your own module. But once you will execute the Terraform init, the very first thing what will happen, it will download all the supporting component. That component could be the modules and the plugins. So let me show you an example. We will open the browser and let's go to the Terraform registry. So we are going to registry.terraform.io, and suppose within your Terraform you are going to use the AWS or GCP. So let's suppose we are going to use the AWS. We will click on the AWS. Over here you can see we are getting a title top downloaded AWS modules. What are these modules? So if you will open the first one, which is a VPC. So VPC means virtual private cloud network. So this module, the VPC module, can be used to spin up the AWS VPC. And within the source code, you need to mention this URL, Terraform AWS modules VPC AWS. So once you are going to execute the Terraform init, what it will do, it will download all the VPC module related code from this particular location in your working directory. So that whenever in future you are going to execute the Terraform deployment, that will not download the code at runtime. So that is the module. What are the plugins? So once the Terraform will execute, it will require a lot of plugins to execute. So what are the necessary plugin for that particular Terraform specific version which is installed on your machine? Terraform init will download all the plugins in your working directory so that you will not face any kind of issue in further execution. So that is the first phase of Terraform init. It will download all the modules, whatever module you are using in your code files or in your configuration file. Plus it will download the plugins which are supporting to your specific Terraform version which is installed on your machine. In the second phase, Terraform will set up the backend. Set up the backend means Terraform init will create the Terraform backup state files where Terraform will store the information of your deployment. So we have learned few points that Terraform init is mandatory for creating the working directory. Terraform init will download the supporting modules and plugins, plus it will create the backend files for your deployments. So that's all about the Terraform init. The actual use we will see once we will execute the lab on Terraform. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss the key concept of Terraform, which is Terraform plan, apply and destroy. These are the commands in Terraform, and we will discuss about the scope of these commands and the key functionality of these commands: plan, apply and destroy. Very first, Terraform plan. Like Terraform init, Terraform plan is a command which will execute after the Terraform initialization. As I mentioned in the earlier lecture as well, Terraform init is a very first command you will execute in any Terraform directory. And Terraform plan could be the second command to execute. This command will read the code files and create and show the plan of execution of your deployment. It means the Terraform plan will read all the configuration which you have written down in the configuration language, and it will show you that what is going to be deployed as a part of that deployment. It will display all the things like the VM machines, the name of VM machines, the IP of VM machine, whatever the network you are going to use, whatever the security group you are going to use, how the security group will be attached. So Terraform plan will execute all the things, that how many resources are going to be deployed as a part of that deployment. so that you can review that plan of your deployment, and if you want any change you can do that particular change. Terraform plan doesn't deploy anything. As I mentioned, that is just show you that what is going to deploy. Actually Terraform plan will just display you that what are the resources are going to be deployed and what are the configuration and properties of these resources. Actually it is not going to deploy anything on the cloud. Terraform plan allow user to review the action plan before execution anything. Definitely if we are getting the complete plan, the complete information of my deployment, then that is the action plan, right? And we can review the action plan before going to execute the things in real. Whenever you will write down the Terraform configuration file, you need to use the credential, you need to use the private key public key combination to interact with the different cloud services, and these credential and these keys must be validate at this particular stage. It means in the Terraform plan stage the authentication of your credential take place, and basically it is going to actually interact with the cloud provider but will not deploy anything. Next is the Terraform apply. So once you have write down the configuration file, you have seen the plan, right? The next thing is deployment, and that is the command. Terraform apply is the command which is actually going to deploy your infrastructure. So whatever you have written down in your code files, whatever you have seen in your plan, once you will execute the Terraform apply, all these resources will start deploying on the cloud. If you already have the deployed deployment and you are making some changes in your configuration file, and then you will execute the Terraform apply, so it will update your deployed deployment. So Terraform apply is used to update the existing deployment as well as create a new deployment from your configuration files. As I mentioned that if some resources are already deployed, then the Terraform deploy command will update the code and update the Terraform tracking files, which are the Terraform state files. Next is Terraform deploy, and that is very straight that this command is used to destroy the deployed deployment by a Terraform. So once you will execute the Terraform deploy, it will look at the Terraform state file and it will start delete all the resources which it will found in the Terraform state files, because Terraform create the track of your deployment and that track mentioned within the state files. So Terraform destroy will read the state file and start deleting the resources which are the part of your state files. Terraform destroy should be used very carefully because this is non-reversible command. Once you will fire the Terraform destroy, you cannot reverse your action, right? So whenever you are going to use the Terraform destroy, you need to be more careful before executing this command. So here is the complete workflow of Terraform. Very first, you will write down your infrastructure as a code, and that infrastructure must be written in the HashiCorp configuration language HCL. Then you will execute the Terraform in that directory to initialize the Terraform. Once Terraform will initialize, it will download all the plugins and the necessary modules. You will execute the Terraform plan. Terraform plan will show you all the resources which you have written down in your configuration file, and it will display what is going to be deployed once you will execute the Terraform apply. If you want any change in any resource, you can update your code file and again execute the Terraform plan. Once you will finalize or review your deployment, to deploy the deployment, you will execute the Terraform apply, and Terraform apply will execute or deploy all the resources whatever mentioned in the code files. And once you are done, you can execute Terraform destroy to destroy that deployment. So on a single page, we have a complete Terraform workflow which is divided in a part. Write down your code, initialize the Terraform, review your plan, make your deployment, and destroy your deployment once you are done. From very next lecture, we are starting to installing the Terraform and executing the labs using the Terraform. First, we are going to execute the Terraform with AWS. So we will see how we can set up the AWS account, how we can set up the Terraform, and then we will see how we can spin up the resources on AWS using the Terraform. And we will also see the Terraform specific scenarios. Once we will done with the Terraform with AWS, in last of this course, we'll work with the Terraform with GCP. So thank you team. From a very next lecture, you will start getting the labs on Terraform. Hello team, welcome back. Welcome to Terraform training, and today we will see how we can create the AWS free account.
So in this course, we are going to use the AWS cloud. And if we are going to create the machines on the AWS, then definitely we need to pay for the uses. But for the practice purpose, AWS provide 1 year free access on the new account. So you need to set up a free account on the AWS to practice this particular course. So let's see how we can set up a free account on the AWS. So let's go to the browser first. Once you will on the browser, type AWS console and you will get the AWS management console link. Let's click this link, and here on the console we are getting create a free account link, and here also we have the create a free account link, right? So you need to click on create a free account link. You need to provide the mail address, password, confirm password, and the AWS account name. So let me provide my details. In your case, you need to provide your details. So here we have provided our details, our email address, the password, confirm passwords, and the AWS account name. Let's click on continue. Here you need to provide the account type, that is the professional or the personal. I will go with the personal option. So here you need to provide few details, like first we need to provide the phone number, then we need to provide the state, then we need to provide the address, and once you provide your details, you need to click create and continue. For the billing purpose, it is required to provide the credit card or the debit card details. Although AWS is not going to charge on your card, but AWS need the billing details so that after the free tier limits, AWS can charge you, right? But don't worry about it. If you are providing the billing details over here, AWS is not charge you up to 1 year. And if you are not using any machine, then definitely AWS is never going to charge you on the AWS account. So we need to provide the credit card details or the debit card details. Then we need to provide the PAN card details, and we need to verify and add. So I'm providing my details and click on the verify and add. In your case, you need to provide your details and click this particular button. Once you will verify your billing details, you will land on this particular page. In some countries, it may ask you to verify your email address or your mobile number. So in that case, you need to verify your email address or the mobile number first, so that you will directly go to this particular screen. Over here, we are getting few plans: basic plan, developer plan, and the business plan. So we will go with the basic plan, which is the free plan. We will click on the free button over here, and it will reload the web page. Now once you will on this particular page, you can go to the my account button over here, and you will go to the AWS management console. Once you will be over here, you need to log in with your email and the password which you have entered. Once you will log in, you will get this particular page, and here you are on the AWS management console. See, we are getting the welcome message over here. You will get some tool tips, and over here you can see here is the account level up 360, and this is the way how you can set up the free account in the AWS. If you want to change the region of your deployment, you can go to this particular drop down, and you can change the region where you want to deploy your machines. So by default it is US East hyphen 2. If you want, you can go to the region 1, you can go to the US East West 2, you can go to the Asia specific regions or the Canada specific regions or the Europe specific regions. I'm going with the default one, which is US East 2, right? So this is the way how we can set up the free account in the AWS. And on this account, we are going to create the deployment with the help of the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. And in last lecture, we have seen how we can set up the free AWS account. Today we will see how we can create the machine for the Terraform execution. It means we are going to create a machine on the cloud, and on this machine we will install the Terraform. So if you have the Windows operating system, if you have the Mac operating system or the Linux operating system, you can directly install the Terraform from the Terraform website. But as we have the audience from the multiple geography, and some are using the Windows, some are using the Mac operating system, some may using the Linux versions, it will be very difficult to support all of the operating system. So what we will do, we will create a central Ubuntu machine on the cloud. As we are learning one of the DevOps technology, so it is required to have the knowledge of the Linux. So that is the another reason why we are going to create the Ubuntu machine instead of using the Terraform on Windows, Mac, or on the Linux box. So now we have the two options. Either we can create a machine on the AWS, for which we have created the free account. But AWS free account machine have the micro machines, right? They don't have the enough CPU and the enough memory powers for the Terraform. So what I will do, I will create a machine on the DigitalOcean. DigitalOcean is the another public cloud platform where we can create the budget friendly machines. So don't worry, you don't need to pay any single penny to anyone. In the next lecture, I have provided the link and the coupon code for the DigitalOcean. With that particular link, with these particular coupon codes, you can get the $135 credit on the DigitalOcean account. And $135 credit is enough to learn this particular course. Even you can execute a machine more than 2 years with the $135 credit. So I'm directly going to the DigitalOcean. What you can do, you can click on the referral link in the next lecture, right? And you can sign up on the DigitalOcean. With that particular link and the provided coupons, you can get the $135 in your account, in your DigitalOcean account, which you can use to create the machine. So let me open the browser and I will type the DigitalOcean. Here we are getting the DigitalOcean Developer Cloud. We will go to the DigitalOcean and I will sign in on my account. In your case, you need to click the link which I have provided in the next lecture so that you will get the referral code attached with your DigitalOcean account. Once you will sign up and sign in your DigitalOcean account, you will get a screen like this. Over here, we are getting a create button. You need to click this particular create button, and over here, we are getting the droplet. Create cloud servers. You need to click the droplet. Here we are getting the different distributions. We want to create the Ubuntu machine, FreeBSD, Fedora, Debian, and CentOS. So we will create the Ubuntu machine, and right now the current version which is available on the Ubuntu is 20.04. If you want, you can choose anyone, but I'm going with the latest version. Here you can see choose the plan. I'm going with the basic plan and I'm going with the lowest plan, the $5 a month plan, right? So this machine will cost me $5 a month. And as per the referral link and the coupon code given in the next lecture, you will have $135 in your account. So you can see you can use this machine more than 2 years, right? Which will be a very enough to complete this particular course. Even you can complete this particular course in just 40 to 45 days. Now I will over here the default data center is already selected. If you want, you can select any other data center. I'm not going to change this. And over here I'm not going to select any additional options, and instead of the SSH key and the password, I will go with the password. So I have provided the valid password, and here are the conditions for the valid password. After this, if you want, you can change your machine name. So suppose I'm going to change it Ubuntu Terraform. This is going to be my machine name. And now I need to click on the create droplet. So this will create a cloud machine on the DigitalOcean. So let's wait, and you can see the machine is created and we are getting the IP to connect with the machine. I will copy this IP and open the terminal. So you can see here I'm on my terminal, and to log in that machine I need to enter SSH root @ and provide the IP of that machine. Hit enter. It will ask for the fingerprint. I will provide yes, and here I need to provide the password which I entered while I was creating the machine. After the password, hit enter, and you can see you are logged in your machine. Clear out the console and see you are inside the Ubuntu Terraform machine. So this is the way how we can create the machine on the droplet and how we can access that particular machine. If you don't have the Linux operating system or the Mac operating system, you need to install Putty or the MOBA Xterm to connect with the client from the Windows operating system, right? If you go with the browser, if you go to the browser and type for Putty, you can see you are getting a link. Download Putty, a free SSH and telnet client for the Windows. Let's open this, and here we are getting the download Putty options. If I will click this, you can see here we are getting the options to download the Putty. If you are a Windows user, you can download this 64-bit version of the Putty, right? You can download it, install it, and use it to connect with the machine. So as we connected with the help of the SSH, right, then we provide the IP on the Putty. Once you will open the Putty, you will get the box where it is mentioned host. Inside the host, you need to provide the IP of your machine and click on the connect. It will ask for the password, enter the password, and you will connect with your machine. If you want to use some advanced tool, you can use the MOBA Xterm. So MOBA Xterm is the another tool to connect with the servers from the Windows. Over here we are getting the MOBA Xterm. You can go to You need to click this get MobaXterm now, and you will get the free edition and the professional edition. We will go with the free edition. Click on the download now, and it will download the MobaXterm on your machine. Install the MobaXterm and use the MobaXterm to connect with the Linux machine from the Windows operating system. So this is the way how we can create the machine on the DigitalOcean, and on this machine we will install the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see how we can install the Terraform. So to use the Terraform, first you need to install the Terraform on your machine. Terraform comes for the all kind of installation. You can install the Terraform on your Windows machine, you can install the Terraform on the Mac machine, and you can also install the Terraform on the Linux box. So we have mentioned earlier as well, multiple users from multiple geography are learning this course. Some users having the Windows machine, some user having the Mac machine, and some are using the Linux box. So to streamline the course and to streamline the commands, we are going to use the cloud machine to install the Terraform. That cloud machine is a Linux machine. So ideally the complete installation and execution of the Terraform will be performed on the Linux box. If you are using the Windows machine or the Mac machine and you are confident, you can install the Terraform locally. But I prefer you can create a cloud machine on the DigitalOcean and install the Terraform on the DigitalOcean machine. As we have already provided the $135 credit in the DigitalOcean, so you don't need to worry about the cost. That credit is more than enough for the 2 years, right? So we are going to SSH the machine which we have created. So you can see over here we are on the Ubuntu Terraform machine which we have created yesterday. First, whenever you will log in the machine or SSH the machine, you need to update the package manager. So we will execute a command sudo apt-get update. Hit enter. It will update the package manager of your machine. It will take some time and shortly it will done. The package manager update is done. Now we will go to the browser and we will see what version of Terraform we can download. So over here we are on the browser and we will type download Terraform. Once you will search for the download Terraform, you will get the first website from the HashiCorp. You need to click it, and here HashiCorp official website is showing the different ways to download the Terraform. We'll scroll down and we will see we have the different versions of the Terraform. For the Mac operating system, you need to download this particular AMD zip file. For the free BDS, you need to download either 32-bit, 64-bit or ARM file. For the Linux, we have the 32-bit, 64-bit or the ARM. For OpenBDS is the same way for the Solaris and for the Windows. So if you are using the Mac operating system or the Windows operating system, you need to go with the 64-bit AMD zip for the Windows and 64-bit AMD zip for the Mac operating system. The current version of the Terraform is 0.13.3. As we are using the Linux, so we will go with the 64-bit Linux box. So I will copy this URL, copy link address, go to my machine and I will type wget and paste the URL. Hit enter. It will download the complete zip and it's done. You can see the total size is 33.26 megabyte, right? The complete file is downloaded in just 0.3 seconds because the speed what I'm getting on my server is more than 100 Mbps. If I will put ls, you can see the Terraform 0.13.13 Linux AMD zip is downloaded over here. For the betterment, let's rename this file. So I will rename the Terraform file with the name like terraform.zip, right? Hit enter, put ls, and file is removed. Now what I need to do, I need to unzip this particular file at some specific location. If you will put ls-lrth, see the size is 34 megabyte, right? The same size which we have downloaded. We will clear out the console, and now what we need to do, we need to unzip this particular zip file. To unzip this file, we need some package manager called unzip. So we will download the unzip via command sudo apt-get install unzip. Hit enter. This will download the unzip on your box, and you can see unzip is downloaded on my box. I will clear out the console, and now I will execute a command unzip terraform.zip. Hit enter. This will unzip the file. Put ls, and you can see we have the Terraform over here. This is the unzip version of the terraform.zip. Now what we need to do, Now what we will do, we will copy this Terraform into some executable location. So we will copy this inside the user local bin. For this, we will execute a command sudo mv terraform user local bin, hit enter. Let's go to the user local bin, put ls, and we have the Terraform over here. Now to verify the Terraform version, you need to execute a command terraform, and Terraform version 0.13.3 is installed on your box. If you simply execute a one more command like terraform, hit enter, see, we are getting the Terraform commands. I will clear out the console, and instead of the user local bin, we will go to the root, right? And from here, we will execute the Terraform command, Terraform version, and see, we are able to access the version. Let's execute the Terraform, and we are getting the complete output of the Terraform as well, right? It means Terraform is successfully installed on my box. If you want to install the Terraform on the Mac machine or on the Windows machine, I will provide an article in the next lecture so that you can follow and install the Terraform on the Windows machine or the Mac machine. But I again repeat, I prefer to use the Linux box for the DevOps tools. So that I recommend you create a machine on the DigitalOcean, the Linux machine on the DigitalOcean, and use the Terraform on the Linux box. If you already have the Linux installed on your local machine, you can use your local machine for this tutorial. Thank you team. See you in the next lecture.
Hello team, welcome back. And in this lecture, we will discuss on Terraform providers and Terraform initialization. We will see what are the Terraform providers which we can use and how we can initialize the Terraform and what are the things which will happen during the Terraform initialization. So we already discussed a bit about the Terraform providers. So providers in Terraform are the cloud vendors to which you want to interact and want to create the resources on cloud using the Terraform. So on whatever the cloud you want to create the resources, you need to use the same cloud provider within your Terraform configuration file. Terraform relies on plugin called providers to interact with the cloud provider. So suppose you want to create the resources on GCP or you want to create the resources on AWS, you need to use the GCP or AWS provider within your Terraform configuration. And whenever you will initialize your Terraform, it will download the mentioned provider plugin in your Terraform working directory and it will start working with that particular cloud provider. Terraform configuration must declare which providers they require so that Terraform can install and use them. So as I just told you that you need to define the provider within the configuration. There's no limitation if you want, there is no such limitation. You can use a single cloud provider or you can use the multiple cloud provider within the same configuration file. There is a very important aspect regarding the provider which you want to understand, that Terraform providers release and Terraform software release itself is a separate thing. You will see a very frequent releases on the Terraform providers, but Terraform software release is not that frequent as compared to the providers. So there is no such dependency that you need to use the same release provider on which release your Terraform is, right? There is no such dependency. Your Terraform software release and the provider release may be different. If you want, you can write down your own providers and there is a complete documentation regarding the implementation of your own provider. Terraform find and install the provider as you initialize the Terraform using Terraform init command. So as soon as you will execute the Terraform init, it will read down your configuration. It will find out that what is the provider you are going to use and it will download and install that particular provider in your working directory. As a best practice, provider should be versioned in your Terraform configuration file. That is very, very important that whatever the provider you are using, you must specify the version of that particular provider. Because if you are not defining the provider's version, it will download the latest version of the provider. And if there is any change in the latest version, then it may impact your Terraform configuration code and it may fail your deployments. So that is very necessary to define the provider's version in your Terraform configuration file. And before using the latest version of the provider, you must verify that specific version within your existing code base. So here we can understand the concept. This is a machine where your Terraform code is running and this is your workstation. Here we have the Terraform providers registry, and from the Terraform providers registry, I want to use the AWS provider and I want to use the Microsoft Azure provider. So Within your Terraform workstation, once you will initialize the Terraform, it will find out that which provider you want to use. It will download that particular provider and install the provider within your machine. Then that provider will be used to create the resources on the AWS or on Azure as the provider configured in your configuration files. So you can easily find out the provider on the registry.terraform.io. So we are on registry.terraform.io, and very first you will land on the provider. So over here you can see you are getting the featured providers, right? If you want to see all the provider, you can go with this link. So we have the AWS, we have the GCP, we have the Azure, we have the Kubernetes, Oracle Cloud, and Alibaba. Let's open some providers like AWS, GCP, and Azure. So here you are getting the AWS provider. This is the current version of AWS provider, which is 3.55.0. If you will open this drop down, you can see the latest version released 5 days ago, and the earlier version released 12 days ago, earlier version released 19 days ago. You can see this provider release is very frequent. Terraform release is not depend on the provider's release. Similar is the case with the GCP provider. Current is 3.81.0, and you can see the frequency is similar to AWS, 20 hours, 8 days, 15 days, 22 days. Similar case could be happen with the Azure, which is 2.73.0, and the release is 4 day, 12 day, 18 day. So basically providers release is very frequent in Terraform. So suppose you are not using the specific version of the provider in your Terraform configuration file. In that case, it always download the latest version. And if your Terraform configuration file are pretty old, they are 6 months old, 8 months old, or 2 years old, then it may possible that the latest provider will impact your Terraform code files, and you are not able to execute the same Terraform code file which was working earlier. So that is a best practice to use a specific version of the provider. And whenever you are planning to move to a next release of provider, first you will validate your Terraform code with that provider and then move on further. So I have created a very simple Terraform configuration file where we are using the AWS and Azure provider, and we will see how we can initialize and install the provider in working directory. So we have created this particular file within the start with Terraform basic. The file name is main.tf. You can see we are using first provider is the AWS provider. We are taking a region US East hyphen 1, and the version what I'm using is 3.53.0. It means we are using 20 days older version. Similarly, for the Azure, we are using like 2.72.0, and the provider name is Azure RM. So you will get the provider name from here. If you want to learn more about this provider, you can go with the documentation and you can learn on this particular provider. So here in this particular configuration file, we are using two providers. You can see the file extension is .tf. So all the Terraform file will have the .tf extension. And here in my local machine, this code editor is a Visual Studio Code. Visual Studio Code is a good code editor, and you may use this to edit your Terraform configuration file or create your Terraform configuration file. If you will install the Terraform plugin within your Visual Studio Code, you will get the Terraform icon as well. You can see all the .tf file. You can see all the .tf file have the Terraform icon. For this, you need to install the Terraform plugin within the Visual Studio Code, which is very basic. Whenever you will create the first Terraform file, it will automatically ask you to install the Terraform plugin within the Visual Studio Code. All the code files which we are implementing throughout this course, all these files are committed in a GitHub repository, and the same repository is already provided within the lecture number 5 in Terraform course. So what I will do, I will copy this and I will go to the machine where I have installed the Terraform. So you can see I am on my Terraform machine. I will create a directory mkdir and I will name it providers. Now I will go to the directory providers, put ls, and there is no file in my provider. I will create a file main.tf, go to the insert mode and paste my source code. See, I'm using the two providers, AWS provider and the Azure provider. I will save this file. Now this providers directory is your workspace for Terraform. To initialize the Terraform, you can simply execute a command terraform init. Once you will execute this command, it will initialize the Terraform. But before initialization, I will set the trace level logs in the Terraform. So I will execute export tf.log equals to trace. This will print all the logs on your console, whatever happened within the Terraform init. Don't worry about the log levels of the Terraform. I will create a separate section on the Terraform logging where I will explain a lot of concept regarding the Terraform logging. Once you will done this, let's execute Terraform init. What it will do, it will read down this main.tf file and initialize the Terraform. Hit enter. You can see it is working and we are getting the trace and debug logs, and finally we are getting Terraform has successfully initialized. Let's move to the starting of this log, and from here you can see it is initializing the Terraform. So the version of Terraform is 1.0.5. Now it is running further and you can see it is initializing the backend. As I told you in the Terraform initialization lecture that it will download the plugin plus initialize the backend. Now over here you can see once the backup is done, you can see it is initializing the plugins, and very first plugin it is downloading the AWS provider. You can see finding HashiCorp AWS version 3.53.0, which we mentioned within my configuration file. First it will download it and then it is finding the another provider version Azure ARM 2.27.0. Now it is downloading the plugins, it is downloading the version, and over here once the download is done, it is saying installing HashiCorp AWS 3.53.0, and now a message installed the HashiCorp AWS version 3.53.0. Further it will work for the Azure ARM, installing the Azure ARM version 2.72, and then it will finish the installation of 2.72. Then it is taking that Terraform has created log file this, and we are getting a warning. Let's ignore this warning, and we are getting a message Terraform has been successfully initialized. Clear out your console. This is the way how you can mention the Terraform and how you can initialize the Terraform to download and install the providers. Let's put ls. So you can see we still have only one directory, but after the initialization Terraform has created a hidden Terraform directory within the same directory providers. Let's execute ls-a, and you can see this is the hidden directory which is being created .terraform. If you will go to this directory .terraform, put ls, you can see over here we have the providers. We will go to the providers, put ls. We are getting the registry.terraform.io directory. Let's go to this directory, put ls, which have the HashiCorp. Let's go to the HashiCorp, put ls. We are getting the two providers AWS and Azure ARM. So what happened once you will executed the Terraform init? First, it is created a hidden directory Terraform which is containing all the necessary installed plugins within the same directory, and it created a .terraform lock HCL. If you want, you can open the content of this file. So let's go to the providers, and once you go to the provider, let's execute cat.terraform.lock.hcl, and within this terraform.lock.hcl file we are getting another information related to my providers. First is the AWS version and hash of my provider, then similarly Azure version and hash of my Azure. Let's clear out the console. So team, this is the way how you can define the providers in Terraform and how you can initialize the Terraform in your working directory. Thank you team, see you in the coming lecture.
Hello team, welcome back. Welcome to Terraform training, and today we will see how we can set up the AWS account for the Terraform. So let's start with. So we are going to set up the AWS account with the Terraform so that we can spin up the machines, the instances on the AWS with the help of the Terraform. For this, we need an AWS account, which we have already created in the previous prerequisite sections. On the AWS account, you need an IAM admin user. We need an IAM admin user which will have all the access on all the resources. So whenever we are hitting the AWS API from the Terraform, that API will be authenticated by this particular user. And if the user don't have the access on the resources, then deployment from the Terraform will be failed, right? So that we need the IAM admin user on the AWS, which will use to authenticate the AWS API from the Terraform. Along with the user, we also need to manage the security groups in the Terraform so that we can whitelist the IP of the machine which is actually hitting the Terraform traffic on the AWS. So the machine which actually executing the Terraform, that is going to hit the AWS API, right? And if we want to deploy the machine on the AWS, then the IP of the Terraform machine is must to whitelist on the AWS. So these are the things which we are going to discuss in this lecture. So let's go to the browser and open the AWS console account. So on the browser, I will type AWS console. We will go to the AWS management console, and inside the my account, we will go to the AWS management console. You need to log in with your user. Once you will log in with your user, you will get this particular screen. Over here, first you need to select the region, which region you want to use. In my case, I'm going to use the US East 2. If you want, you can choose any other region as well. Now, first what we need to do, we need to create the IAM user. For this, either you can go to this services link, right, and you will type for the IAM over here, or we are getting the all services link on the main page as well. Over here, we can search for the IAM, and here we are getting the IAM management access to AWS resources. We will click the IAM. So right now we don't have any users, we don't have any groups and the policies, because this is the newly created account. So we are getting the default roles over here. To create the user, we need to go to the users, and we need to click on the add user. Over here, you need to provide your username. Suppose we are going to provide the Terraform admin. You can provide any name over here. There is no constraint. We are getting two access type options: AWS management console access and programmatic access. Enabled the access key ID and secret access. As we are going to hit the AWS API from the Terraform, so we will go with the programmatic access. Click on the next permissions, and over here we need to assign a group to this particular user. So we will click on create group, and we will create a group over here. Suppose we are going to create a group like Terraform -admin, and we are providing the administrator access to this particular group. Administrator access provide the full access to AWS services and the resources. Click on the create group. Now click on next, which is the tags. This is optional. If you want, you can add the tag. So I'm putting the tag like purpose. It is always helpful to put the tag, and I'm getting Terraform admin. So this is the purpose of this user. Click on review. So this is the username Terra admin. Then we have the programmatic access. The permission boundary is not set. This is the group, and this is the purpose. Let's click on the create user. So you can see the user is basically being created. This is your user. These are the operation which is being performed for this particular user. This is the access key, and this is the secret access key. We will use the secret access key in the next lecture. Right now we have seen how we can create the user in the AWS. Let's close this. Now my user is being created. I will go to the dashboard. Now over here inside the all services, let's go to for EC2, because in the next lecture we are going to launch the EC2 instances. Over here you are getting the dashboard of your EC2. We have the running instances, snapshot, key pairs, IPs, volume, security groups, and the dedicated host and other things. We need to go to the security groups. So either you can click over here, or you can go to the security group inside the network and security section. So we will click on the security groups. As this is the fresh account, so we have one default security group. We need to open this security group, and over here inside the inbound traffic rules, we need to whitelist the IP. So we will go to the edit inbound rules, and we will provide the all traffic, and over here we need to go with the custom, and here we need to provide the IP address, right? So what is the IP address of my DigitalOcean machine? We need to provide that particular IP. So we will go to the DigitalOcean, sign in the account. Here is the droplet which we are using, and here is the IP, right? So I will copy this, go to the AWS. One more thing, if you are using your own machine, if you are using your own Windows or Mac operating machine, you need to provide your own IP over here. For this, if you don't know your IP, you can directly go to the my IP, and AWS will automatically fetch your IP. We are going with the custom one, so we will provide this IP over here, and after this we need to provide some CIDR range. So suppose we are providing the CIDR range 32, right? Now click save rules, and you can see all traffic inbound is basically added over here. So we have created the user, and we have whitelisted my IP inside the EC2 security groups. Rest in the coming lecture, we will see how we can deploy the instance on the AWS with the help of the Terraform. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In the last lecture, we have seen how we can create the user and the security group in AWS. Today we will see how we can create a machine in AWS with the help of the Terraform. So let's go to the code editor. So I'm here inside my Visual Studio Code, and over here I will create a new file and I will name it createinstance.tf. Here we need to provide the code which will be used to create the instances in the AWS. So first we need to mention the provider and then we need to mention the resources. So here is the complete syntax. We need to mention the provider. In my case, the provider is AWS. We need to provide the access key over here and the secret key over here. Then we need to provide the reason on which reason I want to deploy my machine. So suppose we want to deploy the machine is US East 2. Then I'm providing the resources. So over here you need to provide the resource name. I'm providing the AWS instance. The instance name can be provided over here. I am providing like my first instance. Then we need to provide the AMI ID. AMI ID are the images which will be used inside your instance. The image which AWS used to create your instance. And you can go to the browser and identify the AMI. So let's search for the AWS AMI locator. You will get the Ubuntu Amazon EC2 AMI finder. Let's click this. And over here you need to mention the reason for which reason you want the AMI. So suppose you want for US East -2. So here are the AMI for the US East 2 for the Xenial, right? 16.04, 14.02, and for the Trusty 14.04, 14.04, for the Aeon, for the Bionic. So you can select any one. Suppose I'm going to deploy the 16.4 version. So I will copy this AMI and provide in my file over here. The machine which I'm going to deploy is the T2.micro. Inside the access key and the secret key, you need to mention the access and the secret which we have generated in the last lecture. So inside your browser, you have created a user. Let me go to that user. So I will go to the IAM. I will go to the users. I will open this user. Here is the security credentials. And here we are getting the access key, right? What we need the access key plus we need the secret. If you go to the file, you need the secret key as well and you need the access key as well. So over here you can see we are not getting the option to retrieve the secret key again. So what I will do, I will delete this access key and I will generate a new secret. Over here you are getting your access key and over here if you will click on show, you will get your secret. If you want, you can download the CSV file as well. If you will open this CSV file, then you can see you are getting your access key and your secret key as well, right? Let's close this. Once you download that particular CSV file, let's save that particular CSV file at a specific location in your laptop because we need the access key and secret key multiple times. So what I will do, I will copy the access key and I will provide my access key over here in this file. Secret key I will update at a runtime because if I will display the secret key over here, anyone can use my access key and secret key to spin up the resources in my AWS account. So I will save this and commit this file. Once the commit is done, we will go to the terminal. Here is my Terraform machine. I will exit out from the Terraform console, clear out the console and execute git pull. Right, you can see one file changed. If I will put ls, then we are getting my file over here, create instance.tf. I will open the file in a VI mode and I will put my secret key over here. Once you will mention your secret key, you can save your file, clear out the console, and now we will see we have the two files over here, create instance.tf and myvar.tf. Now please remember, whenever you are going to create a new directory or a new file, you always need to execute a command terraform init. This will initialize the Terraform. I'm not going to explain this command again and again in the coming lectures. So please remember, whenever you are creating a new directory or a new file, you always need to execute a command terraform init to initialize the Terraform. Let's hit enter and you can see it is initializing the Terraform and downloading some plugins over here. And few plugins are being downloaded and the plugin HashiCorp AWS version 3.8.0 is being downloaded on my machine. Now after the init, if you want to apply the changes in the Terraform, you can execute a command terraform apply. hit enter. And what this will do, this will spin up the resources on the AWS. You can see over here it is asking for the confirmation and it is providing the details. If you will go with the details, then it is saying it is going to create AWS instance. The instance name will be my first instance, right? We are getting complete message that Terraform will perform the following actions. It is going to create AWS instance. My first instance will be created. This is the AMI which is going to be used. The generate password data will be false and the machine type will be T2 micro. Please make sure you are also using the T2 micro because T2 micro is free for 750 hours a month on the AWS. If we will go down, it is saying source data check true and the other details, right? We are not providing any more details over here, and we are getting the plan 1 to add, 0 to change, and 0 to destroy. Let's put yes, hit enter, and this will spin up a machine on the AWS. You can see we are getting a message AWS instance dot my first instance is being created. If you will go to the AWS account, on the AWS, let's go to dashboard and go to the EC2. You can see we are getting one running instance over here. It means a new instance is basically being triggered by the Terraform. See, we are getting the instance ID and the status check is initializing. If we will go to the Terraform again, then it is saying apply complete resource one edit. It means Terraform is added a resource and this is the ID of the resource. If you will copy this and we will put control F control V, you can see this is the resource ID. It means this resource is basically being created by the Terraform. The resource is running. Now let's go to the Terraform again. Let's clear out the console. Now we have created the machine, right? Now suppose you want to destroy that particular machine. So from the same directory where you have created the machine, you need to execute a command terraform destroy, hit enter, and this will destroy the machine which is being created by the earlier command terraform apply. You can see this is going to destroy the same machine. It is printing the ID of the machine. If you will find it, control F control B, C, this is the same ID, right? And it is asking for the confirmation as well. Provide yes, hit enter, and we are getting the message that AWS instance, my first instance, is basically being destroyed. Let's wait, and we are getting a message destroy complete resource one destroyed. If you will go to the AWS, refresh my AWS, we can see the instance state is terminated. So this is the way how we can create and destroy the instance with the help of the AWS from Terraform. Let's clear out the console. So these are the straightforward command we have seen. But there's one more important command which is terraform plan. So if you will execute a command terraform plan, it will read the terraform configuration file in the current directory and create a plan for you. Let's wait and see. We are getting the complete plan. Let's go to the plan. What it is saying? It is saying an execution plan has generated and it's shown below, right? The resource action which are indicated by the following symbol, it means it have a create resource symbol. This resource is basically will be created and this is the blueprint of that particular resource, right? What is the instance type and the other properties of that particular resource. It is saying 1 to add, 0 to change, and 0 to destroy. Terraform apply will directly apply the changes which is the part of the configuration file, but Terraform plan will display the changes before apply the changes. This is very helpful in the production. Whenever you are using the Terraform in the production or in your organization, it is always helpful to check the Terraform plan before apply that particular plan. Validate that plan. Let's create the plan, validate that plan, and then apply that particular plan. So the plan is 1 to add, 0 to change, and 0 to destroy. If you want to save the output of this particular plan, you can execute a command terraform plan, define hyphen out, and define the file name. So suppose I'm saying my first plan dot out, hit enter, right? It is saying to perform plan exactly these actions, the run following command, this command terraform apply my first plan out. If you will clear out the console and you will ls, you can see a file is being created, my first plan out. Now if you want to apply the changes for which you have created the plan, you need to execute a command terraform apply, put double quotes, and provide the file my first plan dot out. Hit enter and see, this is basically starting the creation of the resources, right? It is saying my first instance is being created. If we will go to the AWS and refresh this, you can see a new instance is basically running over here, right? The ID is ending with 78C1. Over here we are getting the instance is basically created 78C1. So this is the way how we can see the plan which Terraform is going to execute, how we can apply the plan directly, and how we can apply the plan with the help of the file as well. Let's execute the Terraform destroy to destroy the resources which we just created. This is important to destroy the resources once you complete the lab, because we are executing the free account and that have some limitation, right? We need to consume the resources within the defined limit from the AWS. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training. In last lecture, we have seen how we can create the resources and destroy the resources on AWS with the help of the Terraform. Today we will see how we can create the centralized file for the credentials. Because in the last lecture we have supplied the credentials in the Terraform configuration file itself. But that thing is a bit challenging. So first let's see what is the file we have supplied in the last lecture. So in the last lecture we have used this particular file where we have provided the AWS provider, the credentials and the secret key and the reason inside the configuration file. Then we have provided the configuration like the AMI and the instance type, right? So this is a bit challenging because whenever you are working on the production environment, whenever you are working on the testing environment or in some other environment, right, what you will have the multiple configuration file. And in that case, if we are going this particular way, we need to provide the credentials in each and every configuration file, which is a bit challenging scenario. Why this is a challenging? Because whenever we are working in organizations, we have the different projects for the development, different projects for the regression, and different projects for the configuration. You will not face the scenario where the development and the production are working in the same AWS project or same Google Cloud project. No, the Google Cloud or the AWS project for the engineering, for the development, for the regression, and for the production will be the different. And in that case, if you are going to provide the access key secrets in the configuration file, then whenever the infrastructure or the DevOps engineer who are going to deploy the production environment, they need to change the secret key and access key each and every configuration file, right? Sometimes it may possible you may have the hundred of the configuration file. So it is not feasible to put the credentials or the secret key in the configuration file. So how we can separate out these things, how we can provide the single centralized file for the credentials, and the configuration file will read the credential from the centralized files. For this you don't need to do much. You just need to create a one more file over here and name it provider.tf. Right, we have created one more file provider.tf. Now what we will do, we will copy this complete section where we have the provider, the access key, secret key and the reason, cut it from here and provide it inside the provider file. Save it. Now I will commit this code so that I can get the same code on my DigitalOcean machine where we are executing the Terraform. Now we will go to the DigitalOcean machine. Now on this machine we will go to the directory Terraform, right? And here we will execute a command git pull. Now on this machine, after getting the latest code, we will go to the directory, start with Terraform basics. I will put ls and we have the create instance.tf and provider.tf over here. Let's open the provider.tf. So inside the provider.tf, you can see we have the access key, but secret key is still a string, right? I am not mentioning my actual secret key over here. I will update it shortly. Then we are defining the reason. If we will open the create instance.tf, then you can see this file only have the resource section. We are not providing the access credentials inside the create instance.tf. Now to verify this configuration, let's execute terraform.plan and we will get the error. And yes, we are getting the 403 unauthorized request. Why? Because we are not providing the AWS secret key over here. So what I will do, I will replace this string with the actual secret key. Then we will execute the Terraform plan again. So I will replace the secret key. After replace the secret key, I will execute the Terraform plan again. and this time we will see the plan will be successful. So it is creating the plan and plan is successful. It is going to add a resource over here. If we will scroll upside, then you can see it is going to create the my first instance. Let's clear out the console and execute terraform apply. Hit enter and it will create the resource on the AWS. It is asking for the confirmation. We will provide yes, and you can see my first instance creation is initiated. So let's wait until it will create the resource on the cloud, and we can see the resource is created. This is the resource ID 558C. If we will go to the AWS and we will refresh the dashboard, new instance is being created. We will open the instance, and yes, 558C instance is being created on my AWS, right? So this is the way how we can create the centralized provider.tf file, and we will define the credentials inside the provider.tf. So we don't need to provide the credentials again and again in the multiple configuration file. Terraform will read the credentials from the provider.tf file directly and spin up the resources as you demand. After this lab, let's execute terraform destroy so that we can destroy the resource we created. In the coming lecture, we'll see how we can provide the credentials with the help of the environment variable so that we don't need to create the provider.tf as well. That will make the credentials independent from the directory structure. So thank you team. See you in the next lecture. Hello team, welcome back. Welcome to Terraform training, and today we will see how we can supply the credentials inside the variable. How we can supply the credentials by environment variable to the Terraform, so that we don't need to mention the credentials inside the each directory of the Terraform or inside the configuration files. So let me allow to open a file. So if we are going to provide the credentials inside the environment variable, right, then we need to create the environment variable like this. We need to export the environment variable. The key will be AWS access key ID. Over here you need to provide your key. Then AWS secret access key. Here you need to provide your secret, and AWS default reason, and here you need to provide the reason. So let's set all these environment variable in the machine. So first I will set the first one. I will clear out the console. So first we will provide the environment variable access ID, and you need to provide export AWS access key ID, and you need to provide your access key over here. In my case, I need to provide my access key. In your case, you need to provide your own access key. My access key is this. I will hit enter. Now I need to provide the secret. So we need to provide the secret over here, and I need to provide my secret key over here. In your case, you need to provide your own secret. So I have provided my secret over here. Now we need to provide the reason, and here you can provide the reason in which region you want to deploy your machine. I want to deploy in US East 2. Hit enter. Now if you want that the environment variable are basically set in your environment or not, you can provide env pipe grep -i AWS. Hit enter, and you can see all three variables are present inside the environment. There's one more way. You can put print env. It will print all the environment variables in your environment. So over here we can see the all three environment variables are basically present in my environment variables. I will clear out the console. I will go to the Terraform. Then I will go to the start with Terraform basics, put ls, and over here we have the provider.tf. Let's delete the provider.tf. rm-rf, put ls again, and you can see we don't have the provider.tf, right? And in my create instance Terraform file, if I will cat this file, we don't have the secret access ID and the default reason. But as we have the access key, secret, and reason inside the environment variable, so that Terraform will read all three values from the environment variable. If you want, you can execute a command terraform plan. Hit enter, and plan will be successful. Let's see. We are not getting any error. It means Terraform is basically reading the secret, access, and reason from the environment variable. And now to verify, if we will clear out the console and execute terraform apply, it will create the machine on the AWS cloud. Let's wait, provide the confirmation, and it is creating the my first instance on the AWS. Why? Because it is reading the values from the environment variable. So by setting the values, the secret and the access key in an environment variable, you don't need to provide the credentials inside in any file. You don't need to provide the credentials inside the configuration file itself or inside the provider file itself. Because if we are creating the provider file as well, then definitely we need to create the provider file in each directory so that the corresponding configuration file can read the provider. But by the environment variable, we just need to set the environment variable once in a machine, and then the credentials will be read from the environment itself, right? You can see the machine id 5854 is being generated. If we will go to the browser and we will refresh the web page, see, 5854 is being generated. The earlier one is terminated. Now similarly execute terraform destroy to destroy the instance we just created. It will destroy the instance. So team, this is the way how we can handle the credentials inside the terraform. So thank you team, see you in the next lecture. Hello team, welcome back. Welcome to Terraform training. Today we will see how we can create the multiple instances in AWS with the help of the Terraform. Till now we have discussed about the credentials, the way how we can pass the credentials, and we have spin up single instance in the AWS. Now we will see if we have a need to create the multiple instances in the AWS, how we can create multiple instances with the help of the Terraform. So let's go to the code file in Visual Studio Code. So over here I have opened the create instance.tf, and this is the file which we was using to create the instances in the AWS. Now if we want to create the multiple instances, so we need to define few more resources over here. The first resource, we need to define the count, and you need to define the number of instance, how many number of instance you want to create. So suppose I want to create 3 number of instances, right? So I will define 3 over here. Now once you will execute this particular create instance.terraform file, this will create 3 instance in the AWS. Let's do one more thing. This time let's provide the name to your instances. So I am providing one more block tags, and over here I will define name. After the name variable, I will define the value of the name. And suppose I'm providing 3 demo instances, right? And save my file. Now we will go to the machine where we are executing the Terraform. And on this machine, we will go to the directory Terraform. Then we will go to the start with Terraform basics. Put ls over here. We have the create instance.pf present. Let's get the content of this file. And right now I'm not getting the updated content. So what I will do, I will get the git pull. Let's pull the code again. I forgot to push the code earlier, and we can see we have one file changed. Now let's get create instance.tf, and we have the changes which we made. Instance count is 3 and the instance name is 3 demo instances. Now to get the plan, we will execute a command terraform plan, hit enter, and since we need to provide equals over here, right? So the correct syntax will be like tags equal, then braces, then provide the tag. Now we will commit this file. Now we will go to the box where we are basically executing the Terraform, and on this box we will get the git pull. After get the git pull on this box, let's verify the file which we have modified, and we are getting the changes, right? Now let's execute a command terraform plan, hit enter. I'm getting credential error because I recently changed my secret key. So let me update my environment variable. I have updated the environment variable. Let's again execute the terraform plan, and we can see the plan is ready. We are going to add 3 instances, 0 changes and 0 destroyed. Let's execute terraform apply, and let's wait. It is asking for the confirmation. Please provide the confirmation and hit enter button. You can see it is creating my instance 0, my instance 2 and my instance 1. If we will go to the AWS account and we will go to the EC2 instances, then you can see we are getting 3 running instances. Let's open the running instances, and over here we can see that 3 instances are running and all have the name 3 demo instance, the same name which we have supplied inside my code file. See, 3 demo instance. If we will go to the terminal, then inside the terminal we are getting the ID 27C06369 and A7FA. Let's verify the instances IDs. 6396, 27C0 and AF and A7FA. So these are the same instances which is being created by the Terraform. But here we have one challenge. You can see the name of all the instances are similar. Suppose you want to differentiate the name, then how you can differentiate that particular name? So first let's destroy these instances. We will execute terraform destroy, hit enter and go to the code file. Over here, after the instances, let's put some name like demo instance hyphen, then we will provide some dynamic value over here. So we will provide a dynamic value like dollar, then provide curly braces. Over here provide the variable name which we have defined, which is count, then provide dot index, right? So this will create the instance name like demo instance 1, demo instance 2 and demo instance 3, because we are providing this variable and the index of this variable. Let's save this. I will commit the latest code and get the latest code on my DigitalOcean machine. Let's provide confirmation over here for the destroy so that it will destroy the earlier machines. Once destroy will be done, we will get the pull from repository. The destroy is still in progress. Let's clear out the console. Destroy is done and execute git pull. Hit enter and you can see we got the change which we done. If you want to see, I can show you cat create instance.tf and we have the changes over here. Now let's again execute the Terraform plan. Hit enter and plan is to create 3 instances. Let's clear out the console and execute Terraform apply. Hit enter, provide the confirmation and it is creating the instances 0, 1 and 2. Let's wait until it will create the instance, or you can go to your browser directly. In your browser, let's refresh your browser and over here we can see that earlier instance 3 demo instances are being terminated and new instances are being created, demo instance 0, demo instance 1 and demo instance 2. So this is the way how we can provide the unique name to each instance whenever we are creating the multiple instance within the same file, right? So today we have seen how we can create the multiple instance and how we can assign the name to the instance. So thank you team. See you in the next lecture.
Hello team, welcome back. And today we will discuss on Terraform state file concept. We will see what is the importance of Terraform state file in Terraform and what is Terraform state file. So we already have a bit information about the Terraform state file. So Terraform state file is a very important file in Terraform which is used for the resource tracking. Whatever the resource is being created by your Terraform code, the all resource can be tracked by Terraform state file. Terraform state file is a way that Terraform read to identify what has been deployed. So whenever you have deployed few things using the Terraform, all these things, the metadata about these resources and the resources information recorded in a Terraform state file. This file have the record of all the resources, so that is very critical for the Terraform functionality, because once you create your infrastructure using the Terraform and once all the resources are deployed on your cloud, the tracking of these resources is possible using the state file, so that you can understand that how important that file is in future. If you want to update any resource or you want to destroy a few resource, the all resource can be only tracked using this particular Terraform state file. So that is a very critical, and you can say that is a backbone of Terraform. This is also can be seen as a database for Terraform, where Terraform is reading the state file and it is monitoring that these resources are present on the cloud or not, and if they have some different configuration then they will be updated. If you want to delete them, then they can be deleted using the Terraform. Let's understand the complete flow. So here we have the Terraform configuration file, and using this configuration file we are going to deploy few resources like the application server, the application network which application server is going to use, and application database. Here on the right side we have the managed infrastructure where the resources are basically deployed on the public cloud. The application server is basically deployed as a AWS EC2 instance. The network is deployed as a AWS Virtual Private Cloud Network, and suppose the database we are using on Microsoft Azure, which is Azure DB. This is the Terraform configuration file which is used to create this infrastructure on the hybrid cloud where few resources are on AWS and few resources are on Azure. What is the role of Terraform state file in all this process? So once you will create the resources, the record of these resources regarding the metadata, the resource configurations, the resource location and the resource cloud all is being stored in a backup file called Terraform state file. And in future, whatever the change you are going to create in these resources using the Terraform, that must go using the Terraform state file, because before the changes Terraform will read the current configuration of your deployment and then apply the changes on the deployment. Let's discuss more about the Terraform state file. Terraform state file is a flat stored file which is stored in a JSON format, and the default name of the Terraform state file is terraform.tfstate. The Terraform state file is stored in the same working directory where you are executing the Terraform apply command to create your resources. So first you need to initialize, then you can see the plan using the Terraform plan, and once you will execute the Terraform apply, you will see the terraform.tf state is created in the same working directory from where you execute the command. But as this is a very critical file, so Terraform has the provision to externalize this file. It means so you can store the file on the Google Cloud buckets, you can store the file on the AWS bucket, on Azure bucket, or whatever the resource location you want to use, you can store that file on that remote location. As we mentioned multiple times that this is used to resource tracking, so it helps to Terraform calculate the deployment delta. It means you already have the running deployment which is provisioned using the Terraform, and you want to update that deployment. Either you want to add few resources or you want to remove few resources, you can update your configuration. Then after the Terraform configuration file, if you will execute the Terraform plan or Terraform apply, it will calculate the resources, it will calculate the delta of your deployment using the Terraform state file, and it will show you that these are the resources which are going to add within your deployment or which are going to remove from your deployment. There is a warning with the Terraform state file: never lose your Terraform state file. In case you lost your Terraform state file, you are not able to track the deployment which is created using the Terraform. And if you want to perform any action on that deployment, you need to perform that action manually, either that is update, delete, or create new resources. So it is very important that you will create the multiple backup copies of your Terraform state file using the external storage, so that in any case if you lose any of the state file, you can recover that state file and you can reuse your Terraform to create and update the deployment. Let's see a sample of Terraform state file, because we have executed the labs where we have created the three instances in Terraform. So let's see how Terraform state file will look like. So we are on a so we are on our Terraform machine, and we will go to the directory Terraform, and directory starts with Terraform basics. If you will put ls over here, you can see over here we are getting a file terraform.tfstate. This is the Terraform state file for the last execution of this particular directory. Let's get this file terraform.tfstate. Then you can see this is a version file, because the resources are basically destroyed, so that we are not getting anything over here. Let's execute the Terraform plan again. It is saying that three resources are going to add. Let's execute. Let's clear out the console and execute Terraform apply. It will create the resources, provide your confirmation, hit enter, and we are getting message that three AWS instance are being created. Let's wait and go to the AWS cloud, and on instance running we are getting three instance running: demo instance 0, demo instance 1, and demo instance 3. If we will go to the Terraform, that apply completed. Let's clear out your console and get terraform.tfstate file. See, we are getting the JSON data in this file, and it will contain the metadata of all the resources which is being created as a part of this particular deployment. So here we are getting the instances, and all the metadata of that instance, the CPU core count, the CPU thread per, and all the metadata which is related to that particular instance which is being created in the AWS. We are going to destroy these resources. So team, that is the concept of Terraform state file, and we are aware with the functionality and importance of Terraform state file. Thank you team. See you in the coming lecture.